Hi there, and welcome to our lecture on conversions and measurements. It's going to be Math01. Our key idea is how do scientists measure things, and then how do they also convert between this unit of measurement to this unit of measurement. So how do scientists measure things? Scientists use standard units of measure that together form the International System of Units, or the SI system, sometimes referred to as the metric system. And the reason we use SI units because they are more consistent than our standard units of measure that we use here in the US, because we can say 1 millimeter and convert it to meters or centimeters or kilometers very easily, whereas it's not as nice and neat conversion to convert between inches and feet to yards. There's 7 main base units for the SI system. For length we have meter, for mass we use the kilogram, for time we use the second, for temperature we say Kelvin, but often what we'll find is Celsius gets used quite a bit more than Kelvin does. For electric current, it's the amp. For amount of substance, we use the mole. And luminous intensity, we use candela. The thing that we're missing on here, we can throw volume on here as well, which we tend to measure in liters. But volume is basically a cubed unit of length. So if we have 3 dimensions of length, width, height, then we basically have volume as well. So I think that's why volume is not included on this list, but a lot of times we're going to include it as well. So we've got volume is liters. So we can just add that excuse me, to our list really quick. And the unit is L. And then we can also have derived units, which is a combination of base units, like density, which we talked about before. Density is mass in volume, so we have to incorporate both of those things to figure out a derived unit. So it takes more than one of these units to figure it out. So like we saw before, length is measured in meters, and we can also use unit kilometer, decimeter, centimeter, millimeter, micrometer, nanometer. So depending on how big a subject is will depend on which one of these units we use. We'll default at meter. Meter is what we call the base unit, and then we can go up or down from the base unit. A volume we can either measure in cubic meters, so it's a 3-dimensional unit of measurement, unit of length. So we use cubic meter, or we can say it's just simply liters, or we can use cubic centimeter or milliliter, depending on how much volume we have. Mass is measured in kilogram. If we have smaller sample of substance, we use gram, or even smaller is milligram. For temperature, we can use either Kelvin or Celsius. I know we're used to Fahrenheit in the US, and Celsius gets used more than Kelvin does, so we'll probably stick with Celsius. So SI prefixes are used for very large and very small measurements. We saw these on the previous slides already, like milli, centi, kilo. And we use these in multiples of 10. So we've got these prefixes, the SI prefixes for larger measurements. Kilo is used with a lowercase k, means 1,000. We've got mega, which is capital M, which is million. And then we have giga. Most of you might be familiar with giga as a byte. We use bytes for units of storage and electronics. You've heard of gigabytes. It's a billion bytes of information that can be stored. We've got SI prefixes for small measurements. So we've got deci, which are lowercase d, centi, lowercase c, milli, lowercase m, and micro is the Greek letter mu, and then nano is the lowercase n. And they get smaller as we move down this list. And the important thing we want to get out of this particular lecture is that we can convert between small and large numbers. In order to convert to a smaller number, we end up multiplying the measurement by the ratio of units so that you get a larger number. And I'm going to talk about this here in a little bit. And then to convert to a larger unit, we divide the measurement, which ends up giving us a smaller number. So looking at this, say the width of a soccer goal is 7 meters. So what if we want to convert this to centimeters? So we're going to list our given and list our unknown values. So length is in meters, and we want to convert to an unknown, which is centimeters. So we're going to have to determine the relationship between these units. So 1 centimeter is equal to 0.01 meters, or we can say 1 meter is equal to 100 centimeters. And personally, it's a lot easier to use a number when I don't have to deal with decimals, because I can divide by 100 and get the same 0.01. So working through this problem, though, we're going to multiply by 100 because you're converting from meters to a larger unit. So we're going from meters to centimeters, so it takes more centimeters to make up a meter. So we're going to multiply by 100. So what we're doing is taking our given meters, which is 7, multiplying by 100 centimeters. The meters cancel, and we're left with centimeters. Oops. These lines should be here. So meters cancel, and we're left with the unit centimeters. So we have 700 centimeters. Here on the next slide, we've got a little visual that I found on the internet, which is kind of nice to help us figure out what's going on. So we're going to default to the middle. We're always going to default to the middle. This is going to be our base step, our base unit. Say this is the kitchen or something. So this is where we have meters, liters, grams, and then from here we can convert to smaller units. So we got smaller units as we go down the stairs. We got larger units as we go up the stairs. So we had before, say we had our base, because we had 7 meters, and we wanted to convert to centimeters. So we went from 7 meters, and centimeters is down here. So what we ended up doing is taking 2 steps down. So we multiplied. That would be the same as moving our decimal 2 spaces and then filling in zeros and then changing our units. So this is another way to convert our units. This is probably going to be easier than doing it the math way. So we'll practice this a little bit more. Let's see. Say we are given 2,000 millimeters. So we're starting way down here at our smallest unit. Oops. Sorry. We're starting way down here at our smallest unit from our 2,000 millimeters. And the millimeters could be milligrams, it could be milliliters. So this prefix is always the same, but the second abbreviation or second letter that we use is whatever unit we're using. So let's say we want to go from 2,000 millimeters and we want to convert to just meters. So we're going to go from our lowest step, and we're going up 1, 2, 3 to our base step. So that would be the same as if my decimal is here and I moved it over 3 spots. This is the same as dividing by, so for each step that we take, it changes by a unit of 10. So it's the same as dividing by 10, 100, 1,000. So we add a 0 each time. So that's why this works, or this is how this works. Let's say now that we have 2.0 kilograms, and we want to convert to just grams. Pretty useful. Grams is a little more useful in chemistry. So we're starting at our largest unit now, so we're going down 1 step, down 2 steps, down 3 steps to our gram. That's the same as going 10, 100, 1,000, and we're going down, so we are multiplying. So it's the same as moving our decimal over 3 spots, filling in zeros. So here we end up with 2,000 as our numerical value. So we have 2,000 grams. Let's do one more. Excuse me. Let's say that we've got 1,465 centimeters, and we want to show it in kilometers. So now we're at this step, and we're going 1, 2, 3, 4, 5 steps to a larger unit, so we're dividing by 10, 100, 1,000, 10,000, so we're dividing by 100,000. Or we're moving our decimal place to the left, 1, 2, 3, 4, 5 places. So 1, 2, 3, 4, 5. So our new number, 0.01465 kilometers. And we'll practice this a little bit more, but I think that's all we have for now. Oh, no. Just, again, units of measurement, just defining these terms. Length is a measure of a straight line distance between 2 points. Mass is a measure of the amount of matter in an object. Volume is a measure of the size of a body or region in 3-dimensional space. And weight is a measure of the gravitational force exerted on an object. So weight we typically measure in pounds. In the SI system we use newtons, and it is how much mass that object has affected by the gravitational force. And we'll talk more about weight later. So thanks for listening today.